Hi, in this video we'll talk about what are static pods and why they are important. We'll also do some hands-on about static pods. So firstly, what are static pods? So let's understand this with help of an example. So whenever there is a new pod created, then it is the job of the kube scheduler to decide which node this pod should be part of, right? Or the controller manager basically manages the pod. But the question is, if the controller manager is managing the pod, who is managing the controller manager? Or you can say that if the scheduler is deciding which pod should be scheduled in which node, then who is deciding that where the scheduler should be scheduled, which node the scheduler should be part of? So this is why static pods come into play, and all these uh, control plane components like scheduler or these controller manager or Kube API server, all these are static pods. So all these static pods are basically directly managed by the kubelet of that particular node. So all these control plane components like Kube API server or like the controller manager or the scheduler, so all these are actually managed by the kubelet of the control plane. These are all static pods. And now I think you can understand why static pods were required, why they are important, because these are actually the most critical components of the Kubernetes cluster. And these are responsible for working with or managing the other components, for managing the pods and nodes. So it would be a chicken egg problem if it is like, if the kube scheduler is scheduling other pods, who is scheduling the scheduler? So that's why all these are static pods basically. So to mention some of these common static pods, these are like Kube API server, and there is the controller manager, and there is, we talked about scheduler at CD is also a static pod. So all these critical uh, control plane components are static pods basically. Like kubeproxy is also a static pod, and then core DNS is also a static pod. But these are not part of control plane. The ones I've written are the part of control plane. So how do we identify these static pods? You can do that using the annotations. So we'll say kubectl get pods and hyphen capital A. Capital A basically represents all the namespaces. So if you say hyphen n is equals to, let us say, ABC, then it will show you all the pods of the ABC namespace. If you do not specify any namespace, it will give you pods of the default namespace. But if we say capital A, then it will give you the pods present in all the namespaces. So these are all the pods present in all the namespaces. Let us take kube scheduler. So if we do kubectl describe pod and this one, there is an issue. Okay, sorry. What I did was we simply described it, and it was taking the pod from the default namespace, but we have to also specify the namespace, which is kube system. Now it gives us the description of the pod. So if you look at the annotations part, here are the annotations. And if you look at this, so we have kubernetes.io/config.source as a file. So this is how we can identify the static pods. All the static pods would have this annotation basically. If you try looking out for annotations for any other pod, for example, I created this nginx pod. So if I do kubectl describe pod nginx, it is present in the default namespace, so we don't have to specify. So if you go to the annotations part, it says none. So this does not have it. This has no annotations actually. But even if it had some annotations, even at that case, it would not have the annotations we had earlier. So kubernetes.io/config, I think it was slash config. Yes, kubernetes.io/config.source is file. This is how we check for static pods. Now let's see what happens if we remove these static pods. I'm actually using kind cluster here. So in kind, what happens is all these nodes are actually as created as a Docker container. So if I look at Docker PS, you'll see that these are the container names. So kind cluster actually is creating these containers for all the nodes. So all the nodes are as a container here. You'll see I have how many? Three worker nodes, worker 2 and worker 3 and a control plane. So all these are present as a container here. So for that, what we do is we would exec into the container. So I'm doing exec into my control plane here, and I'll use bash. And now I am inside my control plane. So inside the control plane, you have to remember this, that inside the etc slash Kubernetes slash manifest. Inside this folder, you'll find the manifest for these critical components, for the control plane components. So I think I have misspelled somewhere. etc mani manifests, I guess. Yes. So now here we can see that we have the HCD, we have the Kube API server, we have the controller manager, and we have the scheduler, all present as manifests here. And if we delete the manifest here, then it will also be reflected into the cluster. Let us not delete it. Let us simply move the kube scheduler. Let us move it to the temp folder. So now we only have three manifests. So if we exit and if we now say kubectl get pods dash a and we want to grep the scheduler, we won't find any. Or let's also check all the pods, and we cannot find the scheduler here. There is no scheduler here. Yes. Let us create a new pod. Actually, the command is run. Let me take help. So I have to give the name. Let's call it nginx2. Let's take image as image, and I think that is enough. So now the nginx pod 2, the nginx2 pod is created. So if we say kubectl get pods, you will see that the pod is not ready and the status says pending. So what's basically happening is kubectl, let's describe it. You'll see that it is not ready yet. And if we look at the nodes here, you'll see that there is no node. So the pod is not assigned any node here. And why is it so? This is because we have removed the scheduler. So the scheduler is not able to schedule the pod basically. And now this pod cannot run. So how can we fix this? We can bring back our scheduler and let's see if it gets fixed. So we'll do again docker exec. Firstly, let me copy the name of the container, and now let's docker exec into this container with interactive terminal and bash. And now let's bring back our manifest to the etc slash kubernetes slash manifest folder. So we'll say this temp, move the folder from temp, which was kube scheduler, and move it to the etc slash kubernetes slash manifest. So now if I say then I can find my scheduler here. And now let's exit And now let's see kubectl get pods. It says error pulling image. Nginx 2 pod. What is the name of image? I think I made a mistake here. What is the image that I specified? I think I specified the wrong image. Let me go back and see what command I said. Yes. So the mistake I made is that I said create an image of name image. So I should have said Nginx here. My bad. But we got the idea, right? That what is basically happening is with the scheduler, the pod went into a pending state. It was not being executed because it was not being assigned any node. And now as soon as the node was assigned, it initialized and it started being executed, but we had the wrong image, so that's why it could not be executed. So simply we can say kubectl edit this pod, which pod name was nginx2, I guess. So now maybe we can change the image. Let's call it nginx. And now when we will do kubectl get pods, it is in the running state. So this is how it works. Basically, without scheduler, our pods will not be able to schedule unless we are doing manual scheduling. With manual scheduling, we will describe which node this pod should be a part of. So now we do not need the scheduler at that case. But if we are not specifying that this pod should be part of this node, then the scheduler comes into play. And if the scheduler is not present or if the scheduler has some issues, then we will not be able to run these pods. Now let's try removing the Kube API server manifest and let's see what happens. So let's clear this. I'll again see what is the name of the control plane container and I will exec into it again. Docker exec and then interactive terminal. We'll use bash. I think it should be exec then it. Yes. So now let's do the same thing. Let's go to the etc slash Kubernetes slash manifests and let's remove or let's move the Kube API server. Let's move it to temp folder. Now if we do kubectl get pods from all the namespaces that have the word, let's say API only. It is taking some time. Unable to connect to the server. What's the issue? Even I forgot this thing. So I was thinking, why is this saying unable to connect to the server? This is because we have removed the Kube API server itself. So if you remember in the video where I talked about the Kubernetes architecture, what used to happen is whenever we send a request to the Kubernetes cluster, it goes to the Kube API server. And then Kube API server would take it to the etcd and to the controller or to the scheduler. So now if we try doing kubectl, anything about kubectl, whatever you do, get pods or get node, it will not be able to answer because we are simply not able to reach the Kube API server because it's deleted. And now I think we should bring back our Kube API server manifest. So exec into this image, this container, interactive terminal, bash. Again, interactive terminal should be here. It is a flag. Now let's move the temp Cube, Cube API server to etc Kubernetes manifest. And now if we do, now we have our Cube API server manifest back to its place. So now let's exit. And now if we do kubectl get pods, now it starts working again. So I hope you understood why the Cube API server is important and why these are as static pods. So this is how it works. If we remove the Cube API server itself, then the cluster would hang whenever we would want to add anything to the cluster, or we are requesting for anything from the cluster, then it will simply not work, because whenever we send any request, it goes through the Cube API server, which is not present anymore. So that's how the static pods work, and that's what static pods are. I hope it helped you. I hope you were able to understand what's happening when we are deleting all these critical components, all these control plane components, which are there as static pods, and the issues when we delete these YAML manifests, how they reflect in our cluster. So we saw that with the scheduler. If we remove scheduler from our cluster, which is a static pod, if we remove it, then what happens is that it is not able to schedule new pods. So new pods will go to pending state unless they are manually scheduled to a particular node. And we also saw how we can remove the Cube API server. And if we remove the Cube API server, anything you try to access from the cluster, it will start to hang and it will not work, basically because the Cube API server is the point where all the requests go whenever we request anything through kubectl to the cluster. I hope this video was useful, and I'll see you in the next one.